In the last screencast, we talked about units and numbers and measurements. And sometimes in science, we have to convert from one unit to another unit. There's several different ways you can do this. One of the ways to do this is dimensional analysis, and most commonly, dimensional analysis is going to use conversion factors. And we could be doing a conversion in the metric system, like what is shown here, or we can be doing a conversion from the English system to the metric system as well. So when we talk about conversion factors, a lot of times you will see conversion factors presented as 1,000 milliliters in 1 liter. We can write these in two ways. We can write 1,000 milliliters per liter, or we can put the liter in the numerator and the 1,000 milliliters in the denominator. And it just sort of depends on what we are trying to convert to and from. My suggestion here is to make sure you have a really clear numerator and a really clear denominator. This will help you as you are going through and doing these problems. So let's look at the steps for how to do a conversion on the next slide. So when we are doing a conversion and using dimensional analysis, there are 4 steps that you can use to solve these problems. You can determine the units. So what I would first do is determine the units on your final answer. What are you looking for? This is what we call your desired unit, right? And then establish the given information, right? What unit do you have, right? And then decide how to set up the problem. Which conversion factor should be used to get to that desired unit from the unit that you have, and then of course solve the problem. When we look at this, you have your given unit here, and this is your numerator, and you want to put in the conversion factor the given unit in the denominator, because a unit that's in the numerator and then in the denominator will cancel, and you'll be left with your desired unit here. So let's do an example of using these steps with a problem. So you want to make a creamy cleansing balm. The recipe calls for 0.53 ounces. How many grams should you weigh out? And I have the conversion factor here from ounces to grams. You will not need to memorize the conversion factors that go from the English system to the metric system. Those will be given to you. So let's go back and let's talk about step 1. In step 1, right, it asks us for the units of our final answer. And so we here are looking for grams. So I'm going to put a question mark and grams. That's what we need our final answer to be in. In step 2, right, we need to ask ourselves, what are we given? What units are we given? And we're given 0.53 ounces. Now, anytime you see a number with a unit there, that's a context clue. That's generally something important. Yes, we do have some throwaway information every so often in a problem, but most often that's going to be really important information. So those ounces are what we have been given. So in step 3, right, we need to set up the problem. So when I go here to set up my problem, right, I am going to start with what I know. So start with what you know. So we know we have 0.53 ounces. Now, one of the ways that helps me organize my information is I like to draw a line like this and a line like this. I am going to put my conversion factor in that space to get to the units I'm looking for over here, which are grams. Okay, so now I have set up my problem, but I need to fill in the conversion factor. So when I come to fill in the conversion factor, the conversion factor is shown right here, okay? And I can see that I have ounces here in my numerator. That means the ounces need to be in the denominator of the next space. This way they can cancel out. So I'm going to put 1 ounce here, and then I'm going to put 28.35 grams at the top. So the ounces here will cancel, and then I'm left with grams here. That's the only thing that's not canceled out, and that is my unit here. So now what's left is I need to do the math. I put 0.53 in my calculator, and I multiply it by 28.35. Anything that's in the numerator, you're going to multiply. Anything that's in the denominator, you're going to divide. So you could also divide this by 1, but you would get the same answer. So when I put this in my calculator, I get 15.025 grams. But we just learned about significant figures, and we know our answer needs to be in the correct number of significant figures. So when we look at this, we look at what we're given right here, and we see that it has 2 significant figures. We ignore any of the numbers here because this is a conversion factor. It's an exact number, so we ignore it. So we want the answer here to have the same number of significant figures as the answer that we're starting with. So that means that I need 2 significant figures. I look at that 0 to see how I need to round, right? And I don't need to do anything to the 5 then, and I'm going to answer that as 15 grams. Okay. Now you can answer it with a decimal or without a decimal. You can spell out grams, or you can just put a G for the units. Either one, but every answer needs to, when you have a number, you also need to have a unit. So don't leave your unit off on your problems. Let's look at another example. In this example, it says we need to convert 0.0047 kilograms of titanium dioxide, which is commonly used in mineral makeup and sunscreen, to milligrams. So when we sit here and we go through our steps, right, we're going to go step 1. What are we looking for? Well, we're looking to try to get to milligrams, right, which are also commonly shown as mg. Step 2, what we're given is 0.0047 kilograms, which is commonly shown as kg. Now in step 3, we are going to come up with a plan. There are several different ways to do this. Basically what we're trying to do, right, is go from kilograms to milligrams. Now the conversion sheet that I'm going to give you is all going to be relative to a base unit, which would be grams all by itself without any prefix in front of it. This is how I particularly prefer to do the conversions. I call these multi-step conversions or 2-step conversions. If you learned a different way, feel free to do that, but this is also the way that's been successful for most of the students that I've taught. So instead of going directly from kilograms to milligrams, we are going to convert first from kilograms to grams and then grams to milligrams. So when we do this and we set it up, we can set it up all together, right? Where we start with what we know, which is 0.0047 kilograms. And instead of just doing one conversion, I can add another line for the second conversion to get to milligrams. Now, I already know I didn't give myself enough room, so I'm going to give myself a little bit more room here. There we go. All right. So let's first talk about how we go from kilograms to grams. We need to put kilograms in the denominator. That's the unit that needs to go in the denominator. And I know there's 1,000 grams in a kilogram. We talked about this previously on the previous screencast. I'm going to give a handout in class. But these conversion factors are the ones that you do need to have memorized. So when we look at this, these kilograms cancel here. So we have done this step. Now we're looking to go from grams to milligrams. And so I know in 1 gram, there is 1,000 milligrams. Okay, so we can also see here where the grams cancel here and we're left with milligrams, which is the unit that we're looking for. So to solve for this, I'm going to take 0.0047, I'm going to multiply it by 1,000 and multiply it by 1,000 again. When I do this, I get 4,700 milligrams. Now, when we look at this, we have two significant figures that are given here, and we also have two significant figures that are given there. Either of that, you can answer the problem that way. If you put a decimal, though, right here after these zeros, that's going to make it four significant figures, and that would be incorrect. The other thing you could do is you could put this in scientific notation. You could say, hey, look, that's 4.7 times 10 to the third milligrams. Again, in scientific notation, we just are showing our significant figures here. So this needs to have two significant figures, and there's where those significant figures are. Either of these are completely fine to answer. Another common conversion that we will run into will be temperature. Temperature is just the degree of hotness of an object. Let's start over here at Fahrenheit. This is probably the one that you're the most familiar with. Fahrenheit is the one that we use in the United States, where the freezing point of water is 32 degrees Fahrenheit. Room temperature is around 77 degrees Fahrenheit. Body temperature is around 98.6 degrees, and then water boils at 212. If you've been to a country out of the United States, most countries use Celsius, where the freezing point of water is 0, and then water boils at 100 degrees Celsius. Body temperature is around 37, and then room temperature is 25. Science mostly uses Kelvin, where the freezing point of water is right around 273 Kelvin. Room temperature is 298. Body temperature is 310, and then the boiling point of water is 373. So one of the things we're going to look at is converting between these three temperature measurements. These are the equations that we use to convert between the three, and we're going to do an example in a second. When we look at this, if you're trying to solve for the temperature in Celsius, then you would put the temperature in Fahrenheit here, subtract 32, and divide by 1.8. If you are looking for the temperature in Fahrenheit, you would take 1.8 and multiply by the temperature in degrees Celsius and add 32. And for Kelvin, you take the temperature in Celsius and then you add 273.15. I want to point out that you may have memorized another formula or been familiar with another formula that uses fractions instead of the 1.8. I just don't like that as much. So I tend to use the 1.8. But if you love fractions, then feel free to use that 9/5 and 5/9 and all of that business. So let's look at some examples and how to use these formulas. So our first problem here is we're going to convert 75 degrees Celsius to degrees Fahrenheit. So what I need here is I'm looking for my temperature in Fahrenheit. I have 1.8 and I want to multiply that by my temperature in Celsius and add 32. So I'm going to come here, I'm going to take 1.8 and fill in that 75 degrees Celsius and then add 32. This gives us 167 degrees Fahrenheit. As far as significant figures and temperature are concerned, we are not going to worry about significant figures with temperature. Here, we're going to convert -10 degrees Fahrenheit to degrees Celsius. So to do this, we're looking for our temperature in Celsius. So we need to take the degrees in Fahrenheit, subtract 32, and then divide by 1.8. So when we go through and do this, we take -10, we subtract 32, right? And then we divide by 1.8. When we do this math, you should get 23.3 degrees Celsius. Now, I want to add just one more quick problem in here. I want us to convert that -23 degrees Celsius to Kelvin. This will give you experience, or at least a problem to look at where we've done each of the conversions that we just talked about. So to do this, you're going to take the degrees Celsius and you're going to add 273.15 Kelvin, and that will give you the Kelvin. So when we do this, we'll take negative 23 degrees Celsius, add 273.15 Kelvin, and we'll get 250.15 Kelvin. Now, temperature is a lot of times a measurement that we associate with heat and energy. And so I'd like for us now to review energy a little bit. Energy is just the ability to do work. There are two different types of energy that we will talk about in this course. One is kinetic energy, which is just the energy of motion, or like the energy of action as it's sometimes referred to. And then potential energy is the energy of position, which is also another way to think of this is stored energy. So if you look at the picture here, right, if you're biking up a hill, you are moving, you are using energy, that's kinetic energy. You get up to the top of the hill, you're right here, you're at that's potential energy, and then you can roll down the hill, right? And you're moving again, so that's kinetic energy. But while you're sitting on top of that hill, that is potential energy. What are some of our energy characteristics when we talk about this in science? Some of the big things that you need to be aware of is the law of conservation of mass and energy. And when we talk about that, right, energy cannot be created or destroyed. Now, it can be converted from one form to another. So we just saw an example where kinetic energy was converted to potential energy. So energy may be converted from one form to another. So some of the common energy units that you'll run into are a calorie or a joule. When we talk about calories, this a lot of times we're familiar with this because of food calories. So that's calorie like this, and it equals 4.184 joules, which is represented with a J. And so when we talk about a calorie, that's just the energy or the heat energy required to increase the temperature of 1 gram of water 1 degree Celsius. But these are the energy units that we will run into every so often. All right, in the next screencast, we are going to talk about concentration and density.